Imagine looking up at the night sky and seeing not just a blurry star, but a distinct, bright, and clear celestial object. But the individual continents of a planet orbiting Proxima Centauri. Imagine watching clouds drift over an ocean 4 light-years away, or catching the glint of a futuristic city on a world we did not even know existed yesterday. Right now, our best telescopes might show us a tiny pixel of light. But what if we stopped thinking small? What if we skipped the mirrors the size of a living room and built a telescope the size of Jupiter? It sounds like pure science fiction, but the physics says it is possible, and the view would quite literally change what it means to be human. To understand why we need a planetary-scale telescope, you have to understand the limits of light. Telescopes are basically light buckets. The bigger the bucket, the more photons you catch from dim, distant objects. But there is a second, more annoying problem called diffraction. Because light acts like a wave, it blurs as it passes through an opening. To see fine details, you need a massive aperture. If you want to see the surface of an exoplanet in high resolution, a telescope the size of a football field is not enough. You need something thousands of miles wide. Since we cannot exactly pour a glass mirror the size of a gas giant, we have to get creative with a concept called a sparse aperture array. Instead of one giant solid piece, we would launch millions of small, synchronized telescope drones into a massive formation. These drones would fly in a perfect sphere or disk the width of Jupiter, using laser pulses to maintain their positions down to a fraction of a millimeter. By combining the light from all these tiny points, we create a synthetic lens. The resulting image would have the resolution of a single mirror 88,000 miles wide. This is not just a better telescope, it is a time machine and a discovery engine on steroids. With a Jupiter-sized array, we could theoretically map the topography of planets in the TRAPPIST-1 system. We would not be guessing if a planet has water. We would be watching the seasons change on its surface. We could zoom in on the centers of distant galaxies and watch stars being swallowed by black holes in real time, seeing the event horizon with more clarity than a high-definition photo of our own moon. But wait, there is an even wilder way to build a Jupiter-sized telescope that does not require millions of drones. We could use the sun itself. According to Einstein, gravity bends light. This means the sun acts like a natural magnifying glass. If we send a probe out to about 550 astronomical units away, which is about 4 times further than Voyager 1, we can use the sun's gravity to focus light from the other side of the galaxy. This is called a solar gravitational lens. In this scenario, the sun is our lens, and the gravity field it creates is effectively the size of a star. If we positioned a small detector at that distant focus point, we could get an image of a distant planet so sharp we could see individual trees or waves on a beach. Building something this big obviously comes with catastrophic engineering challenges. The amount of data produced by a Jupiter-sized array would be so massive that current internet speeds would look like a dial-up modem from the 90s. We would need onboard quantum computers just to process the light interference patterns. Then there is the sheer scale of the swarm. If one drone malfunctions, the whole array could lose focus. But the payoff is the ultimate answer to the question that has haunted us since we first looked at the stars. Are we alone? A telescope this powerful could detect the atmospheric chemical signatures of industrial civilizations from halfway across the Milky Way. It could see the heat signatures of massive megastructures, or the artificial light of a world that never sleeps. We are currently living in a dark room, peeking through a pinhole. Building a Jupiter-sized telescope is like smashing the wall down and stepping out into the sunlight. It would represent the moment humanity stopped being a local species and started being galactic observers. Even if we never leave our solar system, we would know exactly what is out there, waiting for us. If you think the James Webb Space Telescope brought us incredible images, just imagine what we will see when we finally turn a planet-sized eye toward the dark. It is not just about seeing further into the past. It is about seeing our future clearly for the very first time. If you want to keep exploring the edges of what is scientifically possible, make sure you hit that subscribe button and turn on notifications so you do not miss our next deep dive into the cosmos. Let me know in the comments. If we could point this telescope at any star system today, which one would you choose first?